Imagine a fighter jet that can travel from New York to Los Angeles in under 10 minutes. A machine that thinks faster than any human pilot, an aircraft that becomes completely invisible to enemy radar while flying through space itself. Sound impossible? The Pentagon is already working on it. China has flying prototypes. Russia claims they'll have theirs by 2035. These aren't your grandfather's fighter jets. Today we're talking about weapons that will make the F-35 and even the brand new F-47 look like toys from a museum. The 7th generation fighter is coming, and it's going to change everything we know about air warfare. The race for air superiority just took a dramatic turn. While everyone focuses on the F-35's problems or celebrates Boeing's new F-47 contract win, military engineers around the world are secretly working on something far more revolutionary. Something that will make our current fighters obsolete overnight. Let's talk about what's really happening in the world of military aviation. The F-35 Lightning, despite its troubled history, represents the peak of 5th generation technology. The F-47, just awarded to Boeing in March 2025, promises to be our first 6th generation fighter. But here's the thing nobody's talking about. By the time the F-47 enters service, other nations might already be testing 7th generation capabilities. What exactly makes a 7th generation fighter so special? Think of it this way. The difference between a World War II fighter and an F-35 is huge, right? Well, the gap between today's fighters and 7th generation aircraft might be even bigger. First, let's talk speed. Current fighters like the F-22 can reach about Mach 2.2. That's fast. But 7th generation fighters are designed for sustained hypersonic flight. We're talking speeds over Mach 5. That's more than 3,800 miles per hour. At those speeds, an aircraft could cross the entire continental United States in less than an hour. But speed is just the beginning. These machines will operate in a completely different way than anything we've seen before. Remember how impressed we were when the F-35 introduced sensor fusion? 7th generation fighters will use quantum radar systems. This technology can detect stealth aircraft by exploiting the strange properties of quantum physics. In simple terms, our best stealth technology today will become useless against these systems. Here's where things get really interesting. Boeing just won the F-47 contract worth over $20 billion. That's a lot of money for a 6th generation fighter, but industry experts believe 7th generation development will cost hundreds of billions. Why? Because we're not just building a better airplane, we're creating an entirely new form of warfare. Let me paint you a picture of what combat might look like in 2050. Instead of sending a pilot into danger, commanders will deploy a 7th generation fighter that operates completely on its own. This aircraft doesn't just follow pre-programmed commands. It thinks, adapts, and makes split-second decisions using artificial intelligence more advanced than anything we have today. The AI system learns from every mission. It studies enemy tactics, adapts to new threats, and shares this knowledge instantly with other aircraft in the fleet. Imagine a pilot with perfect memory, lightning-fast reflexes, and the ability to process thousands of data points simultaneously. That's what we're dealing with here. But the real game changer isn't the individual aircraft. It's how they work together. A single 7th generation fighter serves as the command center for dozens, maybe hundreds, of unmanned drones. These aren't simple remote control devices. They're sophisticated weapons platforms that coordinate their attacks with precision that no human pilot could match. Think about the implications. One 7th generation fighter could control an entire air armada. It could overwhelm enemy defenses through sheer numbers while staying safely out of range. The pilot, if there even is one, might be sitting in a bunker thousands of miles away from the action. Now, let's address the elephant in the room. Can these incredible machines actually be built? The technical challenges are enormous. Flying at Mach 5 generates temperatures hot enough to melt steel. The aircraft needs materials that can withstand these extreme conditions while maintaining structural integrity. Current research focuses on metamaterials and advanced ceramics. These aren't just heat resistant. They're designed at the molecular level to have properties that don't exist in nature. Some can actually change their characteristics in response to different conditions. Others can repair themselves when damaged. The Chinese have already shown they're serious about this technology. Their White Emperor program, while still in early development, demonstrates concepts that align perfectly with 7th generation requirements. Photos from Chinese test facilities show aircraft designs that look nothing like traditional fighters. They're flatter, broader, and clearly optimized for hypersonic flight. Russia, despite their current challenges in Ukraine, continues investing heavily in next-generation aviation. Their PAKDP program aims to create fighters capable of space operations. ones. Yes, you heard that right. Fighters that can leave Earth's atmosphere and conduct missions in space. This brings us to another revolutionary capability. 7th-generation fighters won't be limited to atmospheric flight. They're being designed to operate both in the air and in space. This dual capability opens up entirely new tactical possibilities. Imagine an aircraft that can climb to the edge of space, conduct surveillance over vast areas, and strike targets anywhere on Earth within minutes. It could deploy tactical satellites, intercept enemy spacecraft, or conduct reconnaissance missions that current aircraft simply cannot perform. The weapon systems on these aircraft are equally revolutionary. Instead of traditional missiles and bullets, 7th-generation fighters will carry directed energy weapons. High-powered lasers can destroy incoming missiles, disable enemy electronics, or eliminate targets with surgical precision. The challenge with laser weapons has always been power generation. These systems require enormous amounts of energy, far more than current aircraft can produce. 7th-generation fighters will need completely new power generation systems. Some concepts involve compact fusion reactors, others explore advanced battery technologies that don't exist today. Electronic warfare capabilities will be just as impressive. These aircraft can jam enemy communications, disrupt radar systems, and even launch cyber attacks against enemy networks. They'll be able to create false radar signatures, making enemy forces think they're somewhere they're not. Stealth technology will evolve beyond anything we can imagine today. Current stealth focuses primarily on avoiding radar detection. 7th-generation stealth is multispectral. These aircraft will be nearly invisible to infrared sensors, acoustic detection, electromagnetic monitoring, and even visual observation. Adaptive camouflage systems could change the aircraft's appearance in real time. Active cooling systems will eliminate heat signatures. Sound dampening technology will make them acoustically invisible. Advanced materials will scatter electromagnetic signals in unpredictable ways. The manufacturing process for these aircraft represents another breakthrough. Instead of traditional assembly lines, 7th-generation fighters will be produced using advanced 3D printing technologies. Components can be manufactured on demand, allowing for rapid customization and replacement. Some concepts even include 4D printing, manufacturing processes that create components which change shape or properties after they're made. A wing section might reconfigure itself for different flight conditions. Armor panels could become more flexible or rigid as needed. Maintenance will be revolutionized as well. Instead of scheduled maintenance, these aircraft will monitor their own condition continuously. They'll predict component failures before they happen and even perform some repairs automatically. Field maintenance crews could 3D print replacement parts on site, dramatically reducing downtime. The pilot's role, if pilots are used at all, will be completely different. Instead of directly controlling the aircraft, they'll supervise its artificial intelligence systems. They'll make strategic decisions while the AI handles tactical execution. It's like the difference between being a chess player and being a chess master who commands multiple grandmaster level players simultaneously. Navigation systems will be immune to GPS jamming or interference. Quantum navigation uses the fundamental properties of matter itself to determine position. These systems work anywhere, in the atmosphere, in space, even underwater if necessary. Communications will be absolutely secure through quantum encryption. Current encryption methods, no matter how sophisticated, can theoretically be broken with enough computing power. Quantum encryption is different. The laws of physics themselves make it impossible to intercept without detection. Let's talk about the timeline. When will we actually see these incredible machines? Most experts believe 7th-generation fighters won't enter service until the 2050s at the earliest. The technology challenges are simply too complex to solve quickly. However, some breakthroughs could accelerate this timeline. Artificial intelligence is advancing faster than anyone predicted. Quantum computing is moving from laboratories to practical applications. Material science continues making surprising discoveries. The economic implications are staggering. Developing 7th-generation fighters will require investments that dwarf even the most expensive current programs. The F-35 program has cost over $1 trillion across its lifetime. 7th-generation development could cost several times that amount. International cooperation will be essential. No single nation, not even the United States, can afford to develop these technologies alone. We're already seeing partnerships emerge. The United Kingdom, Italy, and Japan are collaborating on 6th-generation development. Similar partnerships will be crucial for 7th-generation success. The strategic implications extend far beyond military applications. Nations that master 7th-generation technology will possess overwhelming advantages in global affairs. Those that fall behind risk becoming irrelevant in international politics. Consider the current situation. The United States maintains global influence partly through superior military technology. Our aircraft carriers project power worldwide because no other nation can effectively challenge them. 7th-generation fighters could provide similar advantages in the air domain, but there's a darker side to consider. These weapons are so powerful that they could destabilize international relations. If one nation achieves a significant technological advantage, it might be tempted to use that advantage before others catch up. This dynamic has historically led to arms races and sometimes to preventive conflicts. The ethical questions are equally challenging. Should machines be allowed to make life and death decisions without human oversight? Current military doctrine requires human authorization for lethal force. 7th-generation fighters might operate too quickly for meaningful human control. Artificial intelligence systems, no matter how sophisticated, make decisions based on their programming and training data. They don't understand context, morality, or the long-term consequences of their actions. Giving such systems autonomous weapons authority represents a fundamental shift in how wars are fought. International law will need to evolve to address these new realities. Current rules of engagement assume human decision-makers. Legal frameworks for autonomous weapons are still being debated in international forums. The environmental impact deserves consideration as well. 7th-generation fighters are being designed with sustainability in mind. Propulsion systems might use hydrogen fuel or advanced biofuels instead of traditional jet fuel. This would significantly reduce the carbon footprint of military operations. Advanced manufacturing techniques could also be more environmentally friendly. 3D printing produces less waste than traditional manufacturing. Modular designs allow components to be recycled or repurposed more easily. Training pilots for these aircraft, if human pilots are used, will require completely new approaches. Current pilot training focuses on flying skills and tactical knowledge. 7th-generation pilots will need to understand artificial intelligence, quantum physics, and space operations. Simulation technology will play a crucial role. Virtual reality systems can create training scenarios impossible to replicate in the real world. AI opponents can provide challenging, unpredictable training experiences that help pilots prepare for actual combat. The maintenance and support infrastructure will be equally complex. 7th-generation fighters will require specialized facilities, trained technicians, and sophisticated equipment. The logistics of supporting these aircraft will challenge military organizations worldwide. Supply chains will need to be reconsidered. Current aircraft depend on components from suppliers around the world. 7th-generation fighters might require more secure, domestically controlled manufacturing to protect sensitive technologies. Cybersecurity becomes critically important. These highly networked aircraft will be attractive targets for enemy hackers. Protecting their software systems from intrusion or manipulation will require constant vigilance and regular updates. The psychological impact on enemy forces could be significant. Facing opponents with overwhelming technological advantages has historically affected military morale and tactical decision-making. 7th-generation fighters might win battles simply by being deployed, but overconfidence could be dangerous. History shows that technological advantages are temporary. Today's revolutionary breakthrough becomes tomorrow's standard equipment. Nations that rely too heavily on technological superiority sometimes neglect other aspects of military effectiveness. Training, doctrine, leadership, and logistics remain crucial regardless of technology levels. The most advanced aircraft in the world is useless if pilots aren't properly trained, if maintenance systems fail, or if commanders don't understand how to employ the new capabilities effectively. Looking at current global tensions, these developments take on special significance. Competition between major powers is intensifying. Nations are investing heavily in military modernization. 7th-generation fighters represent the next phase in this ongoing competition. The United States has historically maintained technological advantages in military aviation. From the P-51 Mustang in World War II to the F-35 today, American aircraft have generally been superior to their opponents. 7th-generation development will determine whether this advantage continues. China's rapid military modernization presents particular challenges. Their defense spending has increased dramatically over the past 2 decades. Chinese engineers have proven capable of developing sophisticated military technologies. Competition in 7th-generation development will be intense. Russia, despite current economic constraints, continues investing in advanced military research. Their engineers have historically produced innovative designs. The current conflict in Ukraine might actually accelerate some development programs as lessons learned drive new requirements. European nations are pursuing their own advanced aircraft programs. The Tempest program, led by the United Kingdom, aims to create a 6th-generation fighter by 2035. European expertise in advanced materials and manufacturing could contribute significantly to 7th-generation development. Smaller nations face difficult choices. Developing advanced military aircraft requires enormous resources that few countries possess. Partnership programs offer opportunities to participate in cutting-edge development while sharing costs and risks. Commercial applications of 7th-generation technologies could be significant. Advanced materials, propulsion systems, and manufacturing techniques often find civilian uses. The Internet, GPS navigation, and many other civilian technologies originated in military research programs. The space industry could particularly benefit. Propulsion systems designed for space-capable fighters might enable more efficient satellite launches. Advanced materials could improve spacecraft durability and performance. Manufacturing innovations could revolutionize civilian industries. 3D printing technologies developed for military applications often find uses in medicine, construction, and consumer products. The economic benefits could eventually justify the enormous development costs. Research and development spillovers historically drive economic growth. The Apollo program, while expensive, generated numerous technological innovations that benefited civilian industries. 7th-generation fighter development could have similar effects. Educational impacts should also be considered. Developing these advanced technologies requires highly skilled engineers, scientists, and technicians. Investment in 7th-generation development drives investment in education and training programs that benefit society broadly. The future of military aviation has never been more exciting or more uncertain. 7th-generation fighters represent humanity's attempt to push the boundaries of what's possible in aerospace engineering, artificial intelligence, and military strategy. The race for 7th-generation supremacy has already begun. While we debate the merits of current fighters, military engineers are quietly working on technologies that will make today's most advanced aircraft look primitive. These aren't just improvements. They're complete revolutions in how we think about air power. The question isn't whether these incredible machines will be built. The question is who will build them first and what that will mean for global security. One thing is certain. The nation that masters 7th-generation technology will possess advantages that could reshape international relations for generations. International scientific cooperation often emerges from military research programs. Shared challenges require collaborative solutions. Even competing nations sometimes cooperate on basic research that benefits everyone. The timeline for 7th-generation development remains uncertain. Technological breakthroughs could accelerate progress while unexpected challenges could cause delays. Political changes, economic constraints, or international agreements could all affect development schedules. Current 6th-generation programs provide some guidance. The F-47 program began serious development around 2015 and won't enter service until the late 2020s. That's roughly 15 years from concept to deployment. 7th-generation fighters involve even greater technological challenges. However, modern design tools and manufacturing techniques might compress development timelines. Computer simulations can test designs more quickly than physical prototypes. Advanced manufacturing can produce test aircraft faster than traditional methods. Artificial intelligence could actually accelerate its own development for 7th-generation applications. AI systems can analyze vast amounts of research data, suggest design improvements, and optimize manufacturing processes. This feedback loop could speed innovation. The role of private industry will be crucial. Companies like Boeing, Lockheed Martin, and Northrop Grumman possess the expertise and facilities needed for advanced aircraft development. Their investment in research and development will determine how quickly 7th-generation capabilities emerge. International partnerships will shape development trajectories. Collaborative programs can pool resources and expertise while sharing costs and risks. The success of programs like the F-35, despite their challenges, demonstrates the potential for international cooperation. The ultimate success of 7th-generation fighters will be measured not just by their technical capabilities, but by their strategic impact. Do they enhance national security? Do they contribute to international stability? Do they justify their enormous costs? These questions won't be answered until these aircraft enter service and prove themselves in actual operations. Until then, 7th-generation fighters remain fascinating glimpses into the future of military technology and the changing nature of warfare itself. The transformation from today's fighters to 7th-generation capabilities represents more than just technological advancement. It reflects changing concepts of military power, international relations, and human-machine interaction. The decisions made about these programs today will influence global security for decades to come. Whether these incredible machines fulfill their promise or join the list of military programs that failed to meet expectations remains to be seen. What's certain is that the pursuit of 7th-generation capabilities will drive innovation, challenge our understanding of warfare, and potentially reshape the international order.